In this video, we're going to revisit a formula that kind of got left to the wayside when we talked about radians. When we talked about radians, right, we saw this formula theta is equal to s over r, and we talked about s being arc length, r being the radius of the circle, right, and theta was the central angle. And so if we rearrange this, we get kind of something that's easier to type, but also something that is actually pretty useful for us. So again, we can talk about the arc length as being equal to the radius of the circle multiplied by the central angle in radians. And so this is one thing that 90% of students, if you are getting incorrect answers, you're forgetting this last little piece. The angle that we're working with must be in radians if we're using this formula. Okay, no degrees. No degrees. Okay, so we're going to look at an example. A large grandfather clock. So if you've seen one of these things, you know, it's a big old, you know, box here type thing, and then it has a pendulum, right? And then, so I'm just going to kind of draw it, and then it swings, you know, from here. So it swings over, and then it swings back, something like this. Okay, so big old pendulum that swings. Okay, and so we're talking about this as being a 2-foot long pendulum. So in other words, this is just my quick sketch. This distance here would be 2 feet, and then it swings through an angle. So the distance from the rightmost part of the swing to the leftmost part of the swing, that angle that it would create, the space that it would swing through, is 3 pi over 8. Okay. So then it says, what is the length of the arc? Okay, well, the length of the arc is down here. Okay, so we're trying to find this. Okay, so then here's my kind of quick diagram. I always recommend making a diagram, but then as I look at this, I'm probably going to have to use the S is equal to R theta formula, but then what is the information given to me in the problem, right? There's a 2, there's a 3 pi over 8. Okay, well, 2, if I think about this, I could kind of create a circle. If the pendulum were to free to swing all the way around, right? Then 2 is my radius. And then the 3 pi over 8, that's in radians. The pi is really cluing me in that it's in radians. But that makes that our central angle theta. Okay, so now I looked at the numbers, introduced symbols, I found a formula, right? And I said, okay, well, S is what I can find. Is that what I'm wanting? Length of the arc. Yes, I do want arc length. So S is equal to 2 times 3 pi over 8. Multiplying this through and simplifying, I get 3 pi over 4. Okay. So that would be my answer. Now, one habit that I like to encourage everyone to get into is if you're given a context problem, respond in context, right? If you're in the real life, in real life, if your manager asks you, you know, what is, you know, the blah blah blah, right? Like, and you're in a certain work context, you're gonna tell them, well, blah 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 is this number, right? You're not just gonna say 22, right? Numbers without units are generally meaningless. So the length of the arc created by the pendulum is 3 pi over 4. And what would the units on this thing be? It's a really good question to answer. So S is equal to the radius is in feet. So I'm just kind of going through this. And then the radians are unitless, right? So our answer is going to be in feet. Okay, so be careful with the units and always respond to context problems with the context answer. Okay, all right. So I want you to take a minute and try the tractor tire example on your own. I'll write out my solution and then kind of run through it, okay? But try it out. So I drew the diagram, okay? So I started with the circle for the tire, and then I said, okay, I rotated by 150 degrees, so I have a central angle of 150, and then the corresponding arc length I have along the edge of the tire, right, is 1.96 meters, okay? So then I went from there, I wrote down all my important quantities, theta, S, and R. R was unknown, and then I said, okay, well, I have theta, S, and R. That has a formula, but theta needs to be in radians, right? So make sure to convert it, okay? You get a completely different answer with 150 in there instead. So then I carried the arithmetic through. Make sure that if you're using a calculator that since you're dividing by a fraction, I generally like to put it in parentheses, and then follow that through, got my answer, and again, context answers or context situations require context answers. So make sure to put it in a sentence. Okay. So great. S equals R theta. Super helpful. Okay. Now we're going to kind of switch gears and look at area. Okay. In case it's been a while, area of a circle is given by the formula pi r squared. Okay. So then imagine we're taking a piece of the circle. Okay. You've taken a piece of cake, probably a bigger piece than you probably should eat because, well, cake is delicious. But so this has a certain area associated to it. Area of a slice, area of a sector. Okay. And so if we look at this area of the sector, right, we can say, well, it's going to be pi r squared times a piece, right? And that piece is some, so if we think of the whole being 2 pi radians, okay, I'm doing radians because, well, we love radians, right? He said with a lot of sarcasm. But if we think about the whole being 2 pi radians, then our piece would be this angle theta that we're interested in. And if I go ahead and simplify this, the pi's would cancel, the 1/2 could come out front, and I'd be left with 1/2 r squared times theta. And again, just to emphasize, theta would be in radians. Okay, so we get the area formula, or area of a sector formula. Area of a sector is equal to 1/2 r squared theta. Okay, and you can see that same formula below. Okay, so one quick example with this. We have a 14-inch pizza pre-cut into 8 equal slices. What is the area of one slice? Okay, we're not talking about volume. We're imagining this is like paper thin. So like, I don't know, Little Caesars pizza or something. Pretty thin. So you can certainly draw a diagram. I'm actually just going to go ahead and write with the formula. Area of a sector is equal to 1/2, and then R. So 14 inches is the diameter, right? So then R is 7. So I'm going to do 7 squared. Okay. And now I need theta. Okay, actually we should probably just get a picture going because, oops. So circle divided into 8. So that's 4. And then you have to divide those each into half. So then if I remember, if this is like 0 and this is 90, then this would be halfway in between. That's 45 degrees, right? So we're saying like if we look at this little piece here from 0 up to this line would be 45 degrees, meaning each central angle is 45 degrees. Okay, but I need it in radians, so multiply by pi over 180, and I get pi over 4 if I simplify. So I'm going to come over here. Actually, I'll do this in black. 1/2 times 7 squared times pi over 4. And if I calculate this out, I love improper fractions, so I'm going to do 49 pi over 8. Okay, and then so context answer, oops, I'm going to say the area, surface area technically, of one slice is 49 pi over 8. Units, area has to be square units, and the units for diameter, or for the diameter were inches, so radius is inches as well. There we go. Okay. So the hardest part usually is actually finding this angle theta. Once you find it, you're good to go. Okay. But make sure that when you're using theta, you're using it in radians, not degrees. You think being in radians is important here?